All right, today we are going on a wild journey deep inside the brain of your computer, the CPU. We're going to find out what actually happens in that split second when you click your mouse.
You ever stop and think about that? It really feels like magic, doesn't it? But here's the secret. Your computer doesn't think at all. Not really. It's just an incredibly fast machine that follows a to-do list, which we call a program, one tiny step at a time. And today, we're going to follow one of those steps, a single instruction on its amazing journey.
So at the very heart of all this is the Central Processing Unit. You know it as the CPU. Its entire mission, its whole reason for being, is just to execute instructions. Think of it as the ultimate taskmaster, just blazing through a to-do list with a speed that is almost impossible to imagine.
Now, the CPU isn't just one single thing. Nope, it's actually a team of highly specialized parts all working together in perfect sync. So let's meet the key players on the team, shall we?
First up, you've got the control unit, or the CU. This is the manager, the big boss. It doesn't do the heavy lifting itself, but it reads every instruction and tells everyone else what to do, where to get the data from, and where to put the results. It's basically the traffic cop for the whole operation, directing the flow of information.
Next, we have the ALU, which stands for Arithmetic Logic Unit. This is the team's math genius, the number cruncher. Anytime a calculation is needed, whether it's adding two numbers or just checking if one thing is bigger than another, the control unit hands the job over to the ALU to get it done, like right now.
And finally, we have registers. And these are so important. The best way to think of them is like little tiny post-it notes right on the CPU's desk. They are insanely fast little storage spots that hold the exact piece of data the CPU needs at that very moment. We're talking instant access.
Okay, so now that we've met the team, we can actually follow a single instruction on its path. This whole process is this constant repeating dance called the instruction cycle, and it really just has three main steps.
I want you to burn these three words into your brain: fetch, decode, execute. This is the fundamental rhythm of every single CPU. First, in the fetch step, the control unit goes and grabs the next instruction from memory. It's just like grabbing the next item on a to-do list. Then comes decode. This is where the control unit looks at the instruction and figures out what it's supposed to do. Is it a math problem, a data move? And finally, you get the execute step, where the CPU actually carries out the command.
All right, this is the execute step. This is where the magic happens. So let's say the instruction was something simple like load data from memory location 100. The control unit points the system to that exact address in memory. The data from that spot is then zipped over into a special high-speed register, usually called the accumulator, so the CPU can use it for whatever's next. And just like that, the command is done, and the whole cycle is ready to start all over again.
Now, understanding that cycle is the foundation, but the real mind-blowing part is the speed. I mean, how does a CPU do this billions of times per second? Well, it really comes down to two key tricks.
The first big secret is the location of those registers we just talked about. Because they are physically inside the CPU, getting data from them is instantaneous. Grabbing data from the main memory, the RAM, well, that's like having to get up and run to another room to find a file. Using a register, that's like grabbing a note that's already sitting on your desk. The speed difference is just massive.
And that speed difference is everything. I mean, get this. If the CPU had to wait for RAM for every single tiny piece of data, it would spend more than 90% of its time just waiting, doing nothing. Our computers would be painfully, unusably slow. Registers are what keep the CPU constantly fed with the data it needs, eliminating that massive bottleneck.
The other big speed-boosting trick is something called pipelining. The easiest way to think about this is like an assembly line. See, instead of waiting for one instruction to go all the way through, fetch, decode, execute, the CPU starts the next one right behind it. So while one instruction is being executed, the next one is being decoded, and a third one is being fetched, all at the exact same time. It's this beautiful overlap that means that once the line is full, the CPU is finishing an instruction on every single tick of its internal clock. It's an incredible boost in efficiency.
So let's just zoom out for a second and appreciate the sheer, unbelievable scale of this whole process. That fetch, decode, execute cycle, it isn't just happening once or twice.
A modern CPU, one running at 4 GHz, can perform this entire cycle, fetching the data, decoding the command, and actually doing it 4 billion times, every single second. That's the kind of speed that powers everything you do,
From opening a file to exploring an entire universe in a video game, it's just staggering.
You know, every click, every keystroke, every single pixel that lights up on your screen is the end result of billions of these simple, elegant cycles firing in perfect harmony. From this tiny fundamental process, our entire digital world is built. It really is the simple, reliable heartbeat that makes everything we do possible. So the only question left is, what will it power tomorrow?